Welcome, my friends. Myself, Mr. Bulakibhav Ashok Aba Sahib, Marathi, Arts and New Commerce Science College, Rajapur. Today's lectures, we are going to discuss the new topic, epoxides. Epoxides are the three-membered heterocyclic ring having oxygen atom in the ring, which is called as oxygen. The most important epoxides are know that the ethylene oxides, ethylene oxides, also known as the oxygen. Compounds also referred as the cyclic ether because it is a three-membered cyclic compound, it having the oxygen atom, so name is a cyclic ether. Another name is a alkene oxide. The next point, we are going to the nomenclatures of the epoxides. Nomenclatures of epoxide are take place in two ways. According to one of these method, the three-membered oxygen containing the ring is called as oxygen with the oxygen at position 1. In the second way, we have see the given prefix epoxy. Two numbers designate the location of the atoms which oxygen is bonded. Now we have seen some examples. How will you given IUPAC name is correctly? In the first examples, the number is start like this: 1, 2, two position having the ethyl group. Therefore, the 2 ethyl oxygen. This three-membered oxygen ring acquired as an oxygen. Is the position 1, is position 2. So two position having the 2 methyl group. This is 1, this is 2. So 2 dimethyl oxygen. Second examples, numbering start like this: 1 position, 2, 3. So total carbon is 3 propane. So 1 and 2 position having the oxygen. Therefore, 1, 2 epoxy propane. Epoxide, therefore, prefix are used as a epoxy. And this position are shown by oxygen, that is one position and the second position. So 1, 2 epoxy propane. Next examples, the number was going like this: 1, 2, 3, and 4. So how many positions having the oxygens? So this second positions, and it is a third position having the oxygen. So 2, 3 prefix epoxy. Total carbon is 4. So name is a butane. Next examples. So one position having the oxygens, CS. A second position is having the oxygen. So 1, 2 prefix are used as a epoxy, and the parent name is a hexane. So which hexane? Cyclohexane. So cyclohexane. Another examples, its prefix are used as a epoxy into 1 and 2 position having the oxygen. So we can write 1, 2, or no write, it is ethane. Next, the one position having the oxygen is attached. Second position having the oxygen is attached. Third position having the substituent. So firstly you can write the substituent at third position. So 3 methyl 1, 2, 1, 2 position having oxygen. So 1, 2 epoxy cyclohexane. Next examples, we can write the numbering is given to this for substituent having the lowest priority. So 1, 2, 3, then 4. So butane. So second position having the substituent chloro. So 2 chloro, 2 3. The position having oxygen. So 2 3, and prefix is a epoxy. Then after parent name is a butane. Next examples. So two position and the third position having the oxygens, and therefore 2 3 epoxy prefix and pentane is a parent name. So 2 3 epoxy pentane. Such examples are, we have see the nomenclatures of epoxide. Next point we have see the preparation of epoxides. Epoxide are prepared by using the three methods. The first method we have see by oxidation of olefins. The oxidation of olefins, direct air oxidation of ethene in presence of the free air using silver catalyst, and to get three membered is epoxide. Similarly, this propane, sorry, propylene, which is oxidized in free oxygen in presence of silver as a catalyst, and to get this propylene oxide derivative. Next examples we have see, sorry, epoxide from per acids. You know that epoxide can also be prepared by using the per acids by action of organic acids on alkenes. The oxygen atom from per acids is added across the double bond and to gives epoxide like this, and this reaction are called as epoxidation reaction or per oxidation reaction of the alkene. The per acids are like the peroxybenzoic acid, peroxyformic acid, then per trifluoroacetic acid. Such examples of the acid can be used for formation of the epoxide ring. The reaction is carried out by mixing of alkene and the per acids. So we have seen these examples. For examples, this alkene are treated with per acids. Any per acid, that is R is having the any group to get the peroxides. For examples, this ethene we have taken presence of per acetic acid, and to got the product is a epoxide, ethylene oxide as a product. Similarly, propylene we have taken in presence of performic acids, to get the product is propylene oxide, and byproduct is performic acid. So such a type of peroxide we have prepared by using the peroxides. And third methods we have going to the preparation of peroxides like alkenes and sorry, alkenes and hypohalous acids like hypochlorite, hyperbromide reacts and to use the halohydrines like this halohydrine. And these halohydrines treat with alkene to gives the epoxide. The compounds which contain halogen and hydroxyl group and adjacent carbon in presence of alkene of water to gives epoxides. For examples, this bromine and water are mixed with each other and to get hypobromide derivatives. Then these alkene are treated with hypobromide and to gives halohydrine, bromohydrine. This is a bromine, this OS, so bromohydrine. Then this bromohydrine, which can be heat with calcium hydroxide, what happens? By loss of this bromine, to get epoxide derivatives, that is ethylene oxide plus calcium bromide is a byproduct. Alkene and hypohalous. Next, if unsymmetrical alkene we have used, the hydroxyl group is attached to carbon atom having the less number of hydrogen atom according to Marconi's. Similarly, last time we have seen this halogen, that is a chlorine in water, to get hypochlorite, that is hypohalous acids. These hypohalous acids are treated with this alkene like a propene and to get halohydrine. Halohydrine, chlorohydrine. Then after formation of the chlorohydrine, last times we have see this OH. OH is attached to which carbon? Carbon having a less number hydrogen according to the Marconi's addition. We have is unsymmetrical alkene. So according to Marconi's addition, this OH is a negative part which is attached to the less number of hydrogen atom. Similarly, after replace this Cl and to get the epoxide derivative. Next point, we have seen some reactions of epoxides. The first reactions we have seen the reactions of acidic condition. In acidic conditions, what happens? The ring opening are take place. We have seen the general reactions like the epoxides. It have tendency to open the ring in acidic conditions because it combines with hydrogen atom of various compounds and to form hydroxyl derivatives. So, in presence of acid, so this lone pair of that oxygen subtract the proton and this A is attack on this side and breaking this bond that take place got the product. Similarly, we have take these examples like a ethylene oxide. This ethylene oxide we have treat or hydrolysis in dilute acid to give the glycol, which on that side and open that side. Being open one. Okay. Next reactions or side reactions are possible in these reactions. Ethylene oxide, which when the treat with excess acid catalyst, add the molecules of the water and to give ethylene glycol. And it is called as hydration. The resulting solution is concentrated up to 70% of evaporation and in fractional distillation process to get the ethylene glycol as the product. The excess of water keeps the formation of polyglycols to the minimum. So such a side reactions which is possible if if we have used the extra or excess acids to get the diethylene glycol. So this is the examples. This ethylene oxide we have treat in acid, open the ring to get glycol. With this glycol are also reacts with this and to get ethylene. Next reaction reactions with acids, halo acid. So these halo acids, firstly the lone pair of that oxygen is abstract the protons and after protonation, breaking this bond by abstract the bromide on that side. Open the ring. So OH on that side and bromine. Such a type of reaction take place in halous acid. Second examples we have see this lone pair of the oxygens are abstract the proton and then protonation. This chloride is attack this side and break this and to get product is a halohydrine. It is a chloro. Next reaction with hydrogen cyanide. When liquefied ethylene oxide and liquefied hydrogen cyanide are react in presence of the catalyst like a calcium oxide, it forms ethylene cyanohydrine. Ethylene cyanohydrine. Similarly, breaking of this type of oxide. So reactions of hydrogen cyanide. Next reactions we have see reactions with alcohols. Reactions we have see the alcohols if epoxide are react with alcohol presence of the dilute acid like a PSO4 forms alkoxy alcohol and this is called as cellulose. This is called as the cellulose. What is mean by cellulose? The epoxides are react with alcohol in presence of dilute acids and to giving the product are named as cellulose. For example, this ethylene oxide reacts with this ethanol in presence of dilute acid. What happens? Break the ring on that sides like this ethylene CH3 CH2 CH2 this O breaking of this side CH2 CH2 is a OH on that sides. So cellulose are placed. The next reactions we are going to the reactions of epoxides in neutral and the basic conditions. Firstly, the basic conditions like ammonia or amines, we have see ethylene oxide when react with ammonia and it form the mixture of 3 amino alcohol and which are known as ethanolamines. We have see these examples of ethylene oxide are treated with ammonia and to got the product is monoethanolamine. Take this side of the ring, OH on this side and NH2 on that side. So monoethylamine. These monoethylamines are treated with another molecules of the ethylene oxide. What happens? The lone pair of that nitrogen is attack on this and breaking of this ring. So what happens? NH, CH2, CH2 and then so diethylamine. Next time what happens? The another molecules we have add like ethylene oxide. What happens? Similarly, the lone pair of the nitrogen which attack on this CH2 and breaking of this ring on that's so first ring add to get green color with the bond or shows that this epoxide being attached. Blue color bond which is attached on that side. So three groups ethyl alcohol group. This is one group, second group and third group. So triethylamine you got the product. Next reactions we are going to reactions with Grignard reagents. Grignard reagents are reacts with the ethylene oxide to form addition product like this, which on acid hydrolysis and to get the primary alcohol. The primary alcohol which is obtained by this method, it contains two carbon atoms more than the Grignard reagent. Here, the starting reactants, it is having only two carbons, but it having a four carbons. So two carbon it will be more on the products. This method, the ethylene oxide is added to well cooled solutions of Grignard reagents, and the mixture is allowed to stand for several hours. The ether is distilled off and residue is treated with ice water. So some examples we are going to these Grignard reactions. The first reaction like this, ethylene oxide are treated in this ethylene magnesium bromide as a Grignard dry ether to get this adduct. This adduct which on hydrolysis to give primary alcohol. It is a N-butyl alcohol. Second examples we have see this ethylene oxide we have add this phenyl magnesium bromide. This phenyl magnesium bromide what happens is attack on this carbon and breaking of this bond. What happens? pH CH2 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 OMGBr, and this adduct which on hydrolysis what happens? This O minus convert to OH, primary alcohol, get the product. Next examples we have see this ethylene oxides we have add this Grignard like a 1, 2, 3, 4. So N-butyl magnesium bromide as a Grignard in dry ether. What happens? The CH2 minus, sorry, CH2 negative charge, magnesium, what happens with charge? Positive charge. CH2 minus is attack this carbon and breaking of this type of bond. What happens? Break this bond. What is the product is here? CH3, CH2, 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 this CH2, CH2, O, MgBr. This adduct which on hydrolysis with water in acidic conditions to get the primary alcohol having the two carbon is more. It is like 1, 2, 3 and the 4 carbon. Final product is 6 carbon. 1, 2, 4, 5 and 6. Next reactions we have see the reactions of alkoxide. So firstly, these reactions are used for preparation of resin. When epoxides are treated with alkoxide like a sodium ethoxide forming oxyanion. This form oxyanion. This oxyanion can again react with another epoxide ring, and this is called as anionic polymerization, and the product is polyalkylene oxide. For example, sodium ethoxides react with ethylene oxide to form polymer of polyethylene oxide, and the reaction is terminated by using dilute HCl. To got the product is it is a mixture of three amino acids like ethanamines which are used emulsifying agents. This is the first applications of the epoxide. Second application, choline, which is prepared by the actions of ethylene oxide are used in vitamin B complex. It is a growth factor in eggs. And third applications, epoxy resins, which are used in polymer industry for the bonding properties. Also used in adhesives such as araldite, extensively used to bind the glass, porcelain metal, and wood.